Hey guys, and welcome back on the YouTube video. Today I'm proud to present to you the first machine learning neural network tutorial on coding movies. Yes, you are in this video. I'm going to be teaching you uh, the very basics of neural networking, and we'll also create a neural network on my own. A lot of effort has been taken into making this video, so please hit that like button and subscribe to the channel if you want some more machine learning tutorials on this channel, which surely they are going to be coming in the future. And myself, I'm thinking on working on really good projects, which I cannot wait to show you guys. Now, for this video, I'm going to be using Google Colabatories, as you can see over here. Now, the reason why I'm doing this is because installing Tensorflow is not the easiest thing, so that's why. And actually, TensorFlow is a module that is made by Google, so that's why we use Google Collaboratories. Google Collaboratories are awesome. They have all the free. They have all the modules of Python that we can use. They don't have some modules like TensorFlow and PyTorch and Scalar if you want any of those things there. So I'd go ahead and just search for collab. Actually, just search for Google Collaboratory. Just search for that and just hit one of these. Now I'm just gonna go ahead and open this Google Collaboratory called TensorFlow tutorial. And let me just get rid of that. So first of all, what is a neural network? A neural network is a computer-stimulated brain to perform a specific task at a very specific level. So let me explain to you better. So I've gone ahead and created this really quick rough diagram of a neural network. So a neural network consists of three layers: the input layer, the hidden layer, and the output layer. So basically, the input layer is the layer that we as a programmer feed to the computer in the form of data. Now, what the input layer does, it will connect everything to the neural network, which is the brain, and it will then the neural network, which is the hidden layer, the middle layer, will actually take that information and it will process all of the information. After processing, it will actually see the testing information also and make its own predictions. Then it will just take this testing data and send it to the output layer in the form in which a human can understand, and then the output layer will display it to the user. So as you can see, I've gone ahead and made this. Now some of this information is taken from a website called Geeks for Geeks, just this part, so you guys can check that out. So the input layer accepts all of the input features. It provides information from the outside world to the network. No computation is performed at this layer. So basically what this means is we feed in some information to the computer on which we want to make all of the predictions. Now the hidden layer nodes in this layers are not exposed to the outer world. They are just part of the abstraction provided by any neural network. Basically this layer is not what any person sees. It's what we as programmers code in. Obviously even we can see it, but like that. And then the output layer is the layer that brings up all of the information that was predicted by the neural network to the user, so we can actually see what the neural network did. Now obviously we are going to be using the TensorFlow library of Python, and we are going to be using our dataset called the digit dataset, which I will explain to you in a second. So yeah, so first of all, I just want to get this thing really clear. In this tutorial, and even in one of the further tutorials, you're going to be seeing a lot of really complicated syntax. Don't get discouraged if you see that. Neural networks, you just need to be having the fundamental knowledge. You need to be good at understanding it, not good at just mugging up code and just spewing it out on your computer screen and getting some output. So just take care of that, because I know you and I got really discussed when I could not learn neural networking because of the syntax. So yeah. So if you guys want to install TensorFlow, just go to TensorFlow's website. It's really awesome. Just go to the installation part and you'll be able to install TensorFlow. It's pretty complicated, so that's why I'm not going to go through that. I had already installed it on an IDE on my Python, but I'm not going to be using it. I just like Google Collaborate. So first of all, we'll just make our standard imports. I'm just going to be copy pasting some of the code over here. forgot what I written all of it. So if you guys want to actually make this code block, just hit plus code and you'll be able to do that. So TensorFlow is going to be used for actually all of the prediction and the neural network. Now as you can see, I've imported Keras from TensorFlow. Keras is like a high level API from TensorFlow that allows you to use a bunch of pre-made datasets which you can use to quickly make a neural network. Now we are also going to be using NumPy for some of the calculations, and we are also going to be using matplotlib for the data visualization. Now we are going to be, first we will load in the data that we will use for the. Now this is one of the, I would say, the most important things in making a neural network because we need data for that. So we are going to be using the MNIST digit dataset to make a digit guessing neural network in Python, which you guys will see. Now, the MNIST digit dataset contains a total of 60,000 training images and 10,000 testing images, which are in the form of handwritten digits from 1 to 9. So, basically, what this is there are going to be in total 70,000 images, which are going to be handwritten, and they're going to be either 1, 2, 3, 4, 5, 6, 7, 8, or 9. So, we just for the computer, it's just going to be 60,000 because 10,000 is going to be tested. So let me explain to you this a bit better. I think most of you guys watching this tutorial will be students, 12 or 14 years, pretty young, I don't know. So, uh, as a student, we all hate exams. So, what it is first we actually need to learn the textbooks, and then we are like tested on all of that skills, and we get the percentage and all of that. Now, for the computer, computers are sometimes pretty dumb. They can just mug up information. They can use their brains. Like if I tell your computer on a laptop to like mug up like 10,000 lines, it can do it in just a second. But if I just tell it to analyze the 10,000 lines and give me some, uh, I'd say, valuable output, it won't be able to do that because computers are not made for that. So for that we use the neural network. So for that what we do is we first take the 60,000 images and we train the computer on those 60,000 images. Then what we do is we take the 10,000 images and then we just randomly pick up an image, the first 10 images or the first 15, it depends on you. And we just take those images, and then what we do is we shove that images to the computer, and we are like, alright, so that's enough that information. Now you need to make predictions on this piece of new data that we are giving, and you need to give me some desired output. So that is just piece output, which is like, if we explain it in a student point of view, it's like we first prepare for the exam, we learn all the textbooks, then we just write the examinations, and then we get the result and the report card and percentage. So we are going to be using the MNIST dataset. To do that, we just go ahead and make a variable called data is equals to keras dot datasets dot mnist. So this is the dataset that we're going to use. So if you haven't already downloaded this dataset, it will go ahead and proceed and download this for you. So just it will do that. Now we will split our data into training data and testing data by using this. Now this is one of the most important parts of making a neural network. Now here's the thing. Computers, as I just told, are awesome at memorizing information, but they are horrible at actually using that information and giving you some desired output or some output that really works. So what we do is we take all of the data and we split it into the training data and the testing data. Also, I forgot to mention it, but I will put a link to this Google Colabatory in the description or in the comment section. You guys can go and check it out for better understanding. So we split it into X-chain and Y-chain. So X-chain and Y-chain is like we split everything into two parts, and X-test and Y-test. And then what we do is the data that we had made up there, we load it into this, and we also split it into four parts. So that is what we are going to do. So let me just go over here, and now you guys can just type it out like as I do. You just need to know what a neural network is. Now we need to specify the class name. So what exactly are the class names? So let me explain. So class names are basically the possible predictions that the model that we have made can predict. Like the model that we have made currently can predict like they're just either 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. Now the model that we have made cannot predict 11, cannot predict 8, 10, cannot predict something like 15 or 20. It can just predict these 10 digits. So that's why. So these are the class names. So they are pretty important. You need some class names to actually um, tell the model that what you can do. Like just take it like as an MCQ examination. You have four options and like the answers in those four options. You cannot get an answer that's like not in there. So that's it. So that's that. So now what we do is now we clean up the data so the computer can use it pretty easily. So now basically the data that we have right now is pretty big. And if you will go ahead and print it out, would have seen that it's composed of a bunch of really big numbers and a lot of really uh, gibberish for humans. So that's pretty bad. So we divided by 255 to get to shorten the numbers so that we can actually the computers can easily use the data and they can function properly. So now what we do is now we can finally go ahead and make the model which consists of the hidden layers. So the actual second layer of the ML model. To do that, we just use this command called model is equals to char with sequential and put up parentheses and the square brackets. And inside we can put in the layers and how those layers should work. So now we are going to be using one flattened and two dense layers, which are the ones that contain neurons. The, the dense layers are the ones that actually contain the neurons, and on the other hand, the flattened layer is used to compress the data into an array which is a perfect square root, which in this case is 784 because the square of 28 is 784. I think most of you guys will not have understood what it is, and also because of my horrible typing that I've done. Uh, so that's why. So basically, as I can see, I've written keras is keras dot layers dot flatten, and then I've written input shape is equals to 28 by 28. So basically, what 28 by 28 is that the shape of the ML model, the array, is a 784. So that's why we need to make it a perfect square root by 28 by 28. Sometimes it's not a perfect square root, then like we do it in a different way, which uh, I am not gonna show you guys right now. It's kind of advanced. Then we just make two dense layers. So the activation is when the it's quite difficult to understand, and I'll probably butcher the explanation for that. So you guys can just go ahead and look it up, but I will just explain it. It's the way the neural network gets activated during all of the prediction and stuff. So we give the activation called ReLU. You guys can look it up. There are a bunch of activations, but I'm gonna go with it. And over here you can see I've created another dense layer with an activation called softmax. So the reason why I gave it this activation is because the way we are divided or the way we are compressed our data. So that's why. So now we need to fit, compile, and make it so the model can actually make the predictions. So as I written here, model.compile, optimizer adding loss past categorical cross entropy and metrics as accuracy. Don't get scared by all of these words. Don't get it's like nothing like that. So basically, compiling the model means we like give the final touch ups. And now, what is the meaning of loss? Sparse categorical cross entropy. The loss is basically it's used to calculate what data the computer could not process and what it could not get right. And the metrics are the accuracy of how accurate the model was, which I feel is pretty self-explanatory. So now we just fit the model, so we show it all of the data for in epoch of 7. So basically, let me actually do what an epoch is. So the word epochs means the number of times the computer is shown the data before testing it. So we show it 7 times. keep in mind that more epochs does not always mean more accuracy. So a lot of people will be thinking, hey, I can make 70 epochs and I can get a 100% accurate model. No, it does not work like that. You need to mess with the neurons, you need to mess with the activation. The reason why epochs does not mean that is because a lot of times if the computer is showing the same data again and again and again and again, it actually can get a little bit confused and lost a lot of things. Like let me explain it better. If I show the computer like a same image of a 7 10 times, and then if I show then the computer will get convinced that a 7 just looks like that, and there can not be any other possible image of 7. So if it's like a difference of 1 or 2 pixels, it can work with it. But if there's a bit of a more difference, like if the 7 has a less of an angle, or the 7 is kind of different, like there are two types of 7s. Let me just like some people draw 7 like this, and some people like to do it in this way. Uh, then the computer won't be able to get 7 patterns. That's it. So that is why we keep like a perfect number of keyboards. Now what we do is we just display the data. So now we just make a quick little for loop for I in range for 10. So this is the number of images that are going to be get displayed, and the model is going to get tested. I'm just checking out on the recording. I'm very nice. So as you know, at top there were 10,000 testing images. So we're gonna test it on 10 images. So yeah. So now all of this is just now the reason why I've kept a CMAP as binary is because the data that we get is always color. Now color data is usually pretty takes up a lot of memory, and it's pretty difficult to process. The reason being color data is in the form of RGB, or it depends, sometimes it's VGR, depends on what type of data you are using. So RGB, if you know, in color data like red, green, blue, the values are pretty high. Like if you go with color like I would say violet, the RGB values are pretty high. Like if you go with something like orange, any color, the RGB is going to be really high, and the computer just gets it really freaks out on seeing a lot of like RGB values being thrown at it, and sometimes it really makes the model very slow and just overall really bad. So that's what we do is we convert it to a CMAP of binary. What a CMAP does, it will convert the RGB values into simple binary type of thing, which is just going to be black and white. Now you might be saying, hey, white is like 255 to 255, but white is pretty easy for the computer to process, and it's also usually in the background, and so the computer can easily analyze that the background, what's the background and what's the exact thing that it actually needs to detect. So now let me actually go ahead and run the code and show you guys the output. So I will need to run all of these cells. That's how it works. Right. So now it's running through the epochs, as which I just told you. So you can see the accuracy right now is 92%, and the loss is, you can see, 0.2. Now it's 96, 97, 98. I think I'll get to a decent 99% of accuracy. I'm pretty happy. 99. And alright, we get a 99.1%. So that's actually good. Now I'm just gonna run this and we're gonna get the output that we want. Alright, there we go. Alright, first of all, give yourself a pat on the back. You made your first machine learning model, your first neural network. So the prediction that a model made on this was 7, and the action was 7. As you can see, the white, the title showed the prediction, and the X label showed the action. The prediction was a 2 and the action was a 2. The prediction was a 1, the action was a 1. The prediction was a 0, the action was a 0. Prediction for 1, 4. There's actually a 5 in here. That's pretty tricky to guess. The last time when I went through it, guessed it wrong. Let's see if it does not. Alright, this is actually right. It used to guess this as a 6. I think it's got really good resemblance to 6 also. Prediction and action. So there we go. you guys made your first machine learning model, your first neural network, I want to say. So that is pretty good. So let me just first get this thing clear with you guys. Um, Now that you have made this model, you might be like pretty proud with yourself. Most of you guys will be like really happy and like will not be able to believe that you actually made a model. Um, yes, you totally deserve this happiness. It's pretty fascinating. What I want you guys to do now is actually experiment with this model and get the accuracy to like kind of I try to get into something like 100, but it's pretty difficult to do that. But 99 is like pretty. I'd say you can work with it. So now, what I want you guys to do is just use this information that you just got and apply it to a project. As you guys would be knowing, I would say a month ago, I have actually done a live stream on YouTube. I did not upload that video afterwards because live streaming, like there were some connection issues in between, and sometimes it was not that smooth, and I was so that's why I later ended up deleting that. So what I want you guys to do is use this data, use this newfound knowledge that you just got, and immediately just apply it to your project. I want you guys to not shut down your laptop right now. Open up Keras. Now I want you guys to go ahead and search for this Keras. I'm not signing for it. Yeah, actually, yeah. Go where Keras Hyperten small image classification dataset. Go over here and create me a. I've actually worked with this dataset also and created a model. You guys will be doing it. You guys have time to actually use the cipher10 small image dataset. Use the load data function. Try and making this a first model. The cipher10 small image classification dataset. Search it up online how it works. I know how it works, but I'm not going to close the bubble. I want you guys to actually learn it by yourself. So the reason why I'm doing this is because even when I learned neural networks, I found it was really good. I really love neural networks. I really love ML. So what I did was as soon as I finished the tutorial series, I just sat down and made this neural network. This is actually my first neural network project. It was made quite a while ago, but still, I'm pretty proud of it. So that is what I want you guys to do. Now, even if you guys think that AI is not that capable, what I want you guys to do is use the fashion MNIST dataset. Don't use the Cypher10, it's kind of advanced. So first use the fashion MNIST dataset and make a machine learning model with that. And the input shapes and all of that are the same, so you guys don't need to include it out. Everything is the same. It's 28 by 28, and everything is the same. And also the class names are given on the website. So just search for that. Create me that fashion MNIST dataset. Make me I'm sorry, the ML model, the neural net, and yeah, make it, and you're gonna be pretty happy. It's pretty good. The fashion feminist reset, it contains of all of the fashion, like it has some antidotes and all of that. Yeah. So this is the entire endless digit data set that we just used, and I hope you guys really like this. And just I cannot emphasize it enough. Please put this in your personal project right away. I know you guys will be thinking that like we will watch one or two more tutorials and then put it in a personal project. No, don't do that. The reason being, neural networks is a pretty complex topic. This was just a super simple neural network. If you guys will use your own data, then it's gonna be the entire next level of complexity. Not to scare you guys, but just so that's why. So please apply this to a project. And I'm actually coming up with another neural network tutorial. Not right now. It's not going to be a tutorial, but stay pumped for that. I'm thinking of making this neural network that will predict that whether you have made a rough paper or scissor, like based on the image of your hand. It's pretty. It's not that difficult. It's all going to be even So, yeah. So this is the entire neural network, and if as I told you, I will drop this entire link in the description, so you guys can go ahead and look at just this code, just in case you guys could not able to do this, and if you guys were not able to open up your Google collaboratories, it's only in the description. You guys can copy that in your browser, you will be able to get into the same Google collaboratory and run out of this code. So yeah, so that is it for this today's tutorial. As I told you, a lot of effort was put into making this tutorial. I need to thank the website Geek for Geek. It's not sponsored or anything, but it's just a website from which I take this paragraph of information and I wanted to cite it. So as I just could not see you anything. So that's why. So yeah. So I will tell you a lot of effort was taken into this. So if you want to just do me a favor, comment down below on this video if you liked this neural network, and if you felt that this video was actually pretty good and helped you out, and also like the video, share the video, and subscribe to the channel. It really helps me out and motivates me to make some more and more fun and free content like this. So until the next time we meet, bye bye.